Hello all. In this video, I will be focusing on the experiment where we learn simultaneous equation method. So the calculation part is explained in this video. This video of theory of simultaneous equation method I have already covered. Okay. In this video, whatever I have covered that will not be repeated here. Before we proceed, just a quick glance. This simultaneous equation method we are following for such sample in which there are two drugs. This sample is mixture of two drugs. Okay. So what is the problem of the sample having two drugs? Is it a problem? No. Having two drugs in a formulation is not a problem. The problem is when I scan this solution in UV. So UV scan gives me UV spectrum. Okay, and what is that UV spectrum? Which is wavelength in nanometers versus absorbance. So whenever I scan this solution, मतलब इस solution में से UV radiations are passing. कौन से UV radiations? All of them, 200 to 400 nanometers. So at each wavelength, at 201, 202, 203, what is the absorbance given by this solution? Okay, that is UV spectrum. So in this case, I get a scan like this. बराबर. So two peaks आए मतलब क्या यहाँ पे है? Because these two drugs are there. Okay. So the problem is both the drugs. This is the lambda max of drug 1. Suppose this is X. Okay. And the another. This is the lambda max of second drug, this which is Y. Barabar? So what do I see here? I see here that both the drugs give absorbance at each other's lambda max. Okay, that is the problem. So what happens because of this problem? Because of this problem, we cannot measure absorbance of individual drug and calculate its concentration. क्योंकि lambda max 1 पे अगर मैंने absorbance लिया तो this another drug is also contributing here. Lambda max 2 पे अगर मैंने absorbance लिया तो another drug is contributing some of its absorbance here, and therefore we cannot directly use this equation A is equal to ABC, which we have obtained from Beer-Lambert's law. Okay, अगर ऐसा spectrum मिलता था separate where their lambda maxes are quite far from each other. Okay, ये lambda max first drug का, ये lambda max second drug का. अगर ऐसे होता था तो क्या होता था? For this mixture एक बार ये वेवलेंथ, सपोज दिस इज 217 एंड सपोज दिस इज 262, तो एक बार मैं 217 पे एब्जॉर्बेंस लेती थी. वॉट एवर इज द एब्जॉर्बेंस वैल्यू आई हैव गॉट हियर, सपोज दिस इज द वैल्यू maybe 63, so that value I would have added in this equation and I would have got the concentration of this particular drug. Second step में what I would have done? Second step में again, the same solution, I would have passed 262 nanometers through it, and 262 nanometer pe whatever is the absorbance. Okay, that absorbance I would have added here. So this will be the concentration of first drugs and this will be the concentration of second drug. Okay, so this for that reason, this absorptivity value, which is A1%, 1 centimeter, we should know. For this drug also A1%, 1 centimeter value we should know. तो ये हम कर सकते थे अगर मेरा स्पेक्ट्रम ऐसा आता था आफ्टर स्कैनिंग. बराबर, तो वो नहीं हुआ ना. तो क्या हुआ उसके बदले मुझे ऐसा स्पेक्ट्रम मिला वेयर बोथ द ड्रग्स आर गिविंग एब्जॉर्बेंस एट ईच अदर्स लैम्ब्डा मैक्स, एंड देयरफॉर वी आर using this method where no physical separation, both the solutions we are not physically separating from each other. Without physical separation, we are just solving the equation simultaneously. Okay, so in Beckett, the textbook for pharmaceutical analysis, Cx and Cy, मतलब ये X का concentration and Y का concentration, उसके लिए direct formula they have given. Okay, so here in this particular video, I will tell you how to carry out the concentration using these two equations. Okay, let us proceed further. So let us see the procedure for preparing standard solution. Now standard solution means what? Standard solution matlab standard X, standard Y. Whenever I call something as standard, that means I know its concentration. Concentration is known. So standard X कैसे बनाना है, standard Y कैसे बनाना है, इसका procedure is given here. Okay, so from the stock solution, which is 1 mg per ml, and here X is ibuprofen. We are withdrawing 1 ml, making up the volume to 10, and same for the second time also. And then we are measuring the absorbance at lambda max of both the drugs. So this is also one more important point which you have to remember. In simultaneous equation method, we measure the absorbance at lambda max of both the drugs. This very nicely I have explained in my earlier video. I request you to please go through that video for the detailed theory of simultaneous equation method. And this is the procedure for preparing standard solution of Y. Y here we are taking paracetamol and this is ibuprofen. This is as per PCI syllabus. So whatever procedure I have written here, the flow chart I have given. See, this is standard X solution. From standard X, अभी देखो यहाँ पे जो लिखा है वो 1 ml we are withdrawing and we are making up the volume to 10 ml. Now from this 10 ml solution, this resultant solution, okay, I am withdrawing 1 ml. Say this 1 ml is this, okay, and then we are making up the volume to 10 ml. So what is the next standard solution? That is Y. यहाँ पे देखो इसमें this is already prepared standard Y stock solution. From this we are withdrawing 1 ml. We are making up the volume to 10, again withdraw 1 and make up the volume to 10. This is the procedure given. और ये जो absorbance measure करना है वो हमें इस solution का absorbance measure करना है. बराबर. Let us see the concentrations. This is 1 mg per ml. ये देखो यहाँ पे लिखा है 1 mg per ml. दोनों भी 1 mg per ml है. So mg per ml को ppm में convert करके this is 1000 ppm. Okay. I hope you are aware of this. 1 mg per ml का मतलब है 1000 microgram per ml, which means 1000 parts per million. Okay, please note down this. Then this second solution, this is 100 ppm. देखो 1000 में से 100 बना and 100 में से 10 बना. ओके, ये कैसे किया वो अगर आपको जानना है तो क्विकली दिखा देती हूँ. C1V1 C2V2. ये 1000 ppm में से C stands for concentration. So 1000 ppm में से 1 ml निकाला और 10 ml बनाया. What is the concentration? Okay, so that concentration comes out to be 100 ppm. Same way using C1V1 ये 10 ppm भी calculate किया. Okay, और in a simple manner you can see here 1000 ppm का 1 to 10 ml dilution 100 ppm, 100 का भी 1 to 10 dilution 10 ppm. Similar dilutions are made for paracetamol also, that is Y. Now next is preparation of sample solution. Now the procedure says that sample which is provided to us is 100 times diluted, and from that solution 1 ml is taken and make up the volume to 10 ml. Again from this 10 ml withdraw 1 ml, make up the volume to 10 ml, and then we have to measure the absorbance at lambda max of both the drugs, and then we have to calculate the content of paracetamol and ibuprofen present in the formulation in milligrams per ml. Okay, so dilution का flow chart I am just showing you here. कौन सा dilution? ये same. Okay, so formulation इसमें से see you can see here in the procedure ये formulation. Okay, ये formulation के अंदर कितना ibuprofen है and कितना paracetamol है, that we have to find out. That is our aim. So the procedure का first line says that this is 100 times diluted. मतलब इसको 100 इसको डाल दिया in volumetric flask and volume was made up to 100 ml. So this is called as sample stock solution. From this 1 ml withdrawn, 10 ml make up the volume. Again withdraw 1 ml and make up the volume to 10 ml. And we have to find out how much is present in this 10 ml first. इसका absorbance लिया. Okay, so from that absorbance we will do the calculation. We will get concentration of this flask first, and then from here we have to find out how much in the formulation. Okay, so this is called as back calculation. And for back calculation we require dilution factor. Dilution factor पे भी एक अलग से वीडियो मैंने डाला हुआ है, that also you can refer. So here you can see dilution factor is this 10 by 1 into 10 by 1 into 100. Okay, so I write it 10 by 1 into 10 by 1 into 100. So basically this is 100 into 100. Okay, this is the dilution factor. This we will be taking during calculation. In lab, what you will find? You will find three such flasks. This is standard paracetamol stock solution, this X is ibuprofen, standard ibuprofen, standard paracetamol stock solution, and this is the 100 times diluted sample solution. Okay, before we proceed, you should know what is the role of these standard solutions here to calculate absorptivity. ओके मतलब क्या मतलब ये 1000 ppm का 1 to 10 अभी हमने देखा वो करके ये वाला जो 10 ppm है इसका कंसंट्रेशन हमने लिया मिला इसका एब्जॉर्बेंस हमें मिलेगा सो ये C पता है ये A पता है तो A इज इक्वल टू ABC से हम लोग एब्जॉर्प्टिविटी फाइंड आउट कर सकते हैं फॉर दिस सॉल्यूशन आल्सो यूजिंग A इज इक्वल टू ABC we know the concentration we know the absorbance substituted here बराबर तो absorptivity find out कर सकते हैं and those absorptivity values then further we will be adding in the formula of Cx and Cy. So role of standard solution here is to calculate absorptivity. So we will see that in detail further. देखो ये फॉर्मूला है Cx and Cy का you can see here A2 ये फॉर्मूला जो है ना ये मैंने एक्सप्लेन किया है in the earlier video. Okay, link I have given in the description box. Quickly I will tell you. मेरे पास दो ड्रग्स है one is X one is Y. Right? So X का 10 ppm का solution I have. Y का भी 10 ppm का solution I have. X का absorbance I am measuring at two wavelengths. एक lambda max of X and second is lambda max of Y. ये वाले lambda max को चलो number 1 दिया. ये वाले lambda max को number 2 दिया. So absorbance of X at first wavelength. ये मेरे पास आएगा then I have A, B, C, Cx and this is AX1. Here absorbance of X again at second wavelength. This is AX2 and Cx. ये कैसे find out करेंगे? ये value, this value you will get from the instrument. This value you know 10 ppm, so you can calculate AX1 and that AX1 you will be substituting here. Same way, this is the absorbance of standard X at second wavelength. कौन सा second wavelength? Lambda max of Y. बराबर तो ये absorbance machine आपको देगा, instrument आपको देगा. This is the concentration which is 10 ppm. बराबर ये 10 ppm हम लेके गए ना 10 ppm solution absorbance के measurement के लिए. बराबर so by substituting in this we can calculate AX2. So ये वो AX2 है. I hope that is clear. And in the same manner ये Y के लिए भी. Okay, देखो यहाँ पे देखो absorbance of Y at first wavelength will give you AY1. Okay, B is always 1, so I'm not talking anything about B. B path length that is 1 for our instrument. Now AY2 absorbance of second drug that is paracetamol. This is Y is paracetamol, X is ibuprofen in our case here. Okay, so absorbance of Y at second wavelength and then AY2 B CY. तो CY तो हमें पता है 10 ppm. ये मैं स्टैंडर्ड की बात कर रही हूँ इसलिए CY हमें पता है. Okay, so this we can calculate. This you will get from the instrument. So after substituting this and this, you can calculate this AY1 and AY2. ये देखो यहाँ पे भी है AY1 and AY2. Okay, now what is this capital A1 and capital A2 in this formula? वो है sample. Sample है ना जिसमें दोनों भी है X and Y. Okay, प्रीवियस स्लाइड पे मैंने आपको 3 फ्लास्क दिखाए थे उसमें से ये थर्ड फ्लास्क है. तो सैंपल का एब्जॉर्बेंस लिया एट फर्स्ट वेवलेंथ. तो ये सैंपल का एब्जॉर्बेंस एट फर्स्ट वेवलेंथ. सो दैट इज BC of X and ABC of Y. I hope you get it. Sample में दोनों भी है ना, तो this absorbance is because of both the drugs X and Y at first wavelength. Same way sample का absorbance लिया at second wavelength. So this is A X to C X plus A Y to C Y. Okay, we are just doing it by the formula method. We will just substitute all these values in this Cx and Cy. Okay, Cx and Cy. Okay, so as I told you, हम लोग 3 फ्लास्क इंस्ट्रूमेंट के पास लेके गए. एक फ्लास्क में स्टैंडर्ड X है, दैट इज ibuprofen 10 ppm. दूसरे में स्टैंडर्ड Y है, दैट इज पैरासिटामोल. और ये सैंपल है. ओके, उसमें का कॉन्सेंट्रेशन वी हैव टू फाइंड आउट. और ये वो फ्लास्क है, हाँ, डाइल्यूटेड वाला, डाइल्यूटेड. इसमें से 1 to 10 एंड 1 to 10. ओके, सो ये वाला फ्लास्क है सबका, तीनों का डाइल्यूटेड. सो 220 जो आया ना हमें, वो 220 हमें आया ये आइब्यूप्रोफेन का. ये देखो आइब्यूप्रोफेन का ना ये ऐसा पी का आया था, ठीक है. और पैरासिटामोल का यहाँ पे ऐसा कुछ पी का आया था. So this is 220 and 242 nanometers. So ibuprofen का absorbance we are measuring at 220 and at 242 also. Paracetamol का भी absorbance we are measuring at 220 and 242 nanometers. Sample का absorbance भी we are measuring at 220 and 242 nanometers. This is 220 nanometers is the lambda max of ibuprofen. 242 nanometers is the lambda max of paracetamol. ओके, एक पॉइंट मिस हो गया मुझसे लास्ट स्लाइड पे, वो ये था कि ऑलवेज रिमेंबर एब्सॉर्प्टिविटी वैल्यू changes as wavelength of measurement changes. ओके, और इसीलिए वेवलेंथ चेंज हो रहा है ना यहाँ पे, इसीलिए हम एब्सॉर्प्टिविटी फाइंड आउट कर रहे हैं यूजिंग स्टैंडर्ड सॉल्यूशन. सो सी हियर, these are the absorbances I have got from the machine. तो एब्जॉर्प्टिविटी फाइंड आउट करने के लिए ये देखो, ये एब्जॉर्बेंस आया ना. अभी ये कौन सा एब्जॉर्बेंस है, AX1. ये कौन सा है, AX2, AY1, AY2, और ये A1, A2. आई होप दिस इज क्लियर. तो अभी AX1 इज इक्वल टू AX1CX, करेक्ट. तो अभी मैं क्या करूँगी, यहाँ पे 0.4808 और ये 10 ppm. फिर AX1 कितना आएगा मेरा, AX1 आएगा 0. ये कितना था, 0.4808. ओके, सो इट इज 0.04808 ऐसे आएगा. आई होप दिस इज क्लियर. तो ऐसे ही कैलकुलेट करके ये सारे वैल्यूज मैंने यहाँ पे टाइप किए हैं. एक्टिविटीज, see all these I have calculated. Now dilution factor here we have understood already. After doing this dilution, the dilution factor is coming out to be, so directly you will get the formulation. I mean, how much is present in this 100 ml? Because whatever is present in the 100 ml, that has come from the formulation. So formulation में उतना mg था, इसीलिए वो 100 ml में ना mg आया. Because other details of the formulation have not been provided to us. और ये dilution factor correct आने के लिए, the way it has been written here on the screen, that is very important. Whenever you are diluting, show the horizontal arrows. Diluting, horizontal arrows. Okay, and whenever you are withdrawing, show the vertical arrows. Withdrawing the solution. Okay, चलो आगे देखते हैं. Now I have done the calculation. See here, यहाँ पे पहले मैंने बताया है कि एब्जॉर्प्टिविटी कैसे कैलकुलेट की. एब्जॉर्प्टिविटी कहाँ से कैलकुलेट की, यूजिंग स्टैंडर्ड सॉल्यूशन, स्टैंडर्ड X and standard Y. Okay, and then all these values have been just substituted in the formula of Cx. और यहाँ से ये Cx आया. अभी देखो यहाँ पे लिखा है ये सोल्यूशन बी, मतलब क्या, ये फॉर्मुलेशन था, फॉर्मुलेशन को 100 में डाला, यहाँ से 1 to 10 एंड अगेन 1 to 10 किया, बराबर। सो दिस इज सपोज सोल्यूशन बी, आप कुछ भी नाम दे सकते हो इसको, नो प्रॉब्लम। सो ये फर्स्ट कॉन्सेंट्रेशन जो आपको मिला आफ्टर सब्सटीट्यूटिंग इन दैट सी एक्स का फॉर्मूला, ओके, ये कॉन्सेंट्रेशन इस फ्लास्क का है। व्हाई? बिकॉज दैट फ्लास्क ओनली वी हैव टेकन फॉर मेजरिंग द एब्सॉर्बेंस। तो ये कॉन्सेंट्रेशन जो मिला ये इस फ्लास्क का है। व्हाट इज अवर एम? टू फाइंड आउट ये फ्लास्क में, इसीलिए कॉन्सेंट्रेशन इन ए is calculated by concentration in B multiplied by dilution factor. Okay, so 94.60 milligrams per ml में we have just converted it. Same way CY के formula में we have just substituted everything. So CY क्या है? Concentration of paracetamol in solution B, बराबर ना? Solution B that is 1 to 10. Okay, ये B solution है और ये A solution है. This flask we had taken for the measurement of absorbance. इसका absorbance हमारे पास है. So that absorbance and the related calculations we have substituted here. So this is the concentration of Y in this B solution. And now to get the concentration of Y in this solution, this concentration of B multiplied by dilution factor. And the answer is coming out to be 91.87 milligrams per ml. I hope the calculations are clear, and this is how you have to report the result statement. Content of ibuprofen in the formulation was found out to be 94.6 mg per ml by simultaneous equation method, and the content of paracetamol in the given sample was found out to be 91.8 mg per ml. अभी अगर content in the formulation बोल रहे हैं तो आप सिर्फ mg भी लिख सकते हो, okay? Content of paracetamol in the given formulation, if we are saying formulation, then you can directly say 91.8 mg. तो अगर सैंपल सोल्यूशन में कितना है, कॉन्सेंट्रेशन, कॉन्सेंट्रेशन अगर बोला, ओके, तो कॉन्सेंट्रेशन के लिए ऑलवेज इट विल बी mg per ml. I hope you have understood. If there are any queries, you can always write in the comment section. Thank you.